How's it going, everybody? And welcome back to another installment of Tech Support Thursday. I wanted to answer some of these questions as you guys seem to enjoy. So I encourage you, if you don't already, comment on stuff and you're like, I'm not really sure. It never hurts to ask, right? The only dumb question is the one you don't ask. So, I mean, you can Google it if you want. But, if you're anybody like me and you Google something, you get 20 million results and you're like, okay, and you jump around, so that type of stuff. So, I did want to make a couple of comments before I actually get into the Tech Support Thursday questions. And that is going to be that if you guys have design questions, because there was a gentleman that commented a couple times about a particular scenario that he was looking at. Let me know ahead of time that some context to the question. So I don't have a problem answering questions, whether they're design questions or technology questions. Whether you're what do you think about this particular design, or having a trouble understanding why this particular thing is in place, so on and so forth. I do my best to try to take my knowledge base of information and then go through it and try to give you guys a response to it that might be useful or helpful. So the one thing that I will be clear on is, if you are actively working on a customer project and you're asking me to kind of like do a peer review, I draw the line there. I won't do that. So that there's some legality stuff. So that's going to be on you to figure out. You to have internal conversations with your peers to basically do your due diligence as an engineer, right? I would never come to YouTube and be like, "Hey guys, this is what I'm thinking about doing. This is a active customer engagement. What do you think?" I can't do that, right? I mean, any engineer worth their salt is not going to go out to the internet on a YouTube video and be like, I'm not smart enough to do it myself, which, it's one of those things where you got to have a level of confidence. So, but if you guys have questions regarding, I don't understand why this is in place, or could you help me understand this design, I'm happy to do those things. But one thing I won't do is do your job for you. So that's where I draw the line. And I've talked about this numerous times in the past, where I would, especially back when I was a full-time instructor, and I would have students that were get kind of crabby because I wouldn't build the lab for them. And I'm like, well, here's the deal. Put yourself in a real world network engineering job, and you've been given a task with a project, and you have to come up with a proof of concept. So your job is to reach out to vendors and schedule meetings and ask questions and gather business requirements and all that type of stuff to try to figure out which way is the best way to do something. There might be 5 different vendors that can all do the same thing or relatively closely. It is your job to work through the vendors and eventually come down to the one that you're going to go with. So I can't do that for you, and you're going to have to put in the time and effort. That's what engineering is all about. So there's also a question about what is the 80-20 rule when it comes to being an engineer. And the answer to that question is very, very simple. So you take a 40-hour work week, which is what normally what people will work. There is going to be especially if you're working in IT, there's going to be oftentimes, especially if you're a deployment engineer where your job is to implement solutions, where you're going to have your 40-hour work week, roughly, and then you're going to have after-hours work, where you're working from, say, 7, 8 o'clock at night until 10, 11, 12, 1, 2 in the morning, depending on what's going on, if things break, so on and so forth. The 80-20 rule, the 80% of that, is you're doing the bulk of the work when there's nothing going on. Meaning you're doing your research, you're testing things out, you're talking to people, you're trying to figure stuff out. There's documentation, there's Visios, there's Word docs, there's videos, you're having meetings about stuff. You're doing all of the heavy lifting when you're not in the middle of a change window. The 20% is the actual part that you're doing something. The change window, the migration window, whatever you want to call it, That's where that piece comes into play. The 80% piece, let's say that's 32 hours of your work week. If you work a 40-hour work week, that's going to be that bulk of time. All the downtime when there's no meeting, you don't have to be anywhere at a particular time. Maybe you're in the lab trying to figure something out, but you're figuring stuff out. You're working through the solution to try to figure out which way you're going to go with it. That's the 80 part of that. The 20 part is where it's 8 o'clock at night, the change window has started, emails go out that things are starting, and you're about to go do your thing, right? And then you spend whatever time you need to in that. Maybe, the other part of that would be 8 hours. So it's a little bit different when you're a consultant and you have multiple customers. So I used to work on average 55 to 60 hours a week. So I'd work my normal 40-hour work week, 9 to about 6 at night, and then from 8 o'clock, 9 o'clock, 10 o'clock at night. Sometimes it would be later, 1 o'clock, 2 o'clock in the morning, depending on the customer, where you'd have to stay up, or so I would try to take a nap so that I would be somewhat coherent at 2 o'clock in the morning, and then I would work until that's done, and then I would take a couple hours and try to get some rest before I would start the next workday. So it was my job to kind of balance that. That's a little bit different because you don't work for a customer directly. You're working for multiple customers as a third-party consultant. That's a little bit different, but the 80-20 rule still applies. So I wanted to get that out there because it seems like that's, especially if you've never heard the concept before, I wanted to clear that up. But these are some of the things that you're going to have to think about as you're doing your engineering stuff and all the good stuff that goes along with that. I actually really enjoy engineering, which is one of the reasons why I'm constantly playing around with technology and things like that. I still have to do Visios and document how I think stuff will work and paint the picture, take what's in my head and put it on paper, that type of stuff. I live in a very logical world, so a lot of people don't know what we do, right? If you were to take 100 people, and you were to ask them what do they think a network engineer or systems engineer in IT does, they're going to be like, they work on their computer. They're not going to have a clue what we do, right? But the reality of it is we live in a very logical world. They see, stuff, and they really probably couldn't even put a finger on what that stuff is or what it does. You guys and I know what they do and how they work and why they're there. So it's our job to take all of that knowledge and put it into easy to understand terms. So anyway, I wanted to get that out there. And hopefully that helps and is worth your time and effort. So I wanted to start answering a couple of these questions, and there's a couple questions that came in just recently that I wanted to scoot to the top and handle and things like that. So we'll get through this as quickly as we can, but also try to be as thorough as we can. So the first question is, why do many ISPs that manage the customer edge have the two CE routers connected physically and have an IBGP as an overlay? What would the point to control incoming traffic and do router role swaps for secondary being the primary and so on? Why would many ISPs that manage customer CEs, customer premise equipment or CPE, routers connected physically and have an IBGP as an overlay? Would the point to control incoming traffic and do router role swaps for secondary being the primary and so on? I'm a little so if I follow your question, what it sounds like to me you're asking is this. You have PE1, you have PE2, then you have, assuming that's what's happening here, then you have CE1 and then you have CE2. You have these guys connected like so, and then you have a link between the two. And whether this is a tunnel or a physical connection, and why do you run BGP between them? And so would the point to control incoming traffic and do router role swaps? So assuming that there's some sort of LAN segment back here, where you're doing maybe something like this, where there's first hop redundancy maybe. So yes, that's one way to do it. So typically speaking, let's assume for just a moment that this guy here is your primary, and this is your secondary. And you're doing BGP between the two. There's eBGP peerings from PE1 and PE2 to CE1, CE2, respectively. So what you would do is, if this is your primary point from a local preference perspective, you could put in here an LP of, say, 200 for any routes that are learned from the provider, and then that would get propagated to CE2. So, and would go that direction. So the idea here is a failover scenario. Okay? So the failover scenario is where this may be your primary HSRP, and this is it primary backup? Primary backup. They always confuse me. Anyway, not important. This would be primary. This would be secondary. So your LAN traffic should go this way, out towards CE1, and then out to the internet, right, via PE1. That would be the ideal direction. But if something were to happen where something happened with this leg, where the connection between the LAN and CE1 went down, well, then traffic would end up going to CE2 because this would no longer be secondary. This would become primary. Traffic would hit CE2, but the internet link might still be up. So you would end up sending traffic this way based off the local preference and then out this direction. Okay, that would be an ideal solution. Now, would that work? It would. Is that the ideal way? Maybe not. Maybe it is. Depends on the scenario. Now, let's say, for example, let's back this up a little bit. Let's say that this link didn't go down. So the SFP didn't crash, or the structured cabling is fine. Let's say this box took a dump. Or, yeah, let's stay with that. This box took a dump. Well, if this box goes down, whether it's, let's say it's power. Power went out of in that closet. Well, everything's going to immediately fail over to this guy. This becomes primary, and then traffic goes out this way, right? That's going to be how the failover would work. Now, what would happen if, for example, traffic, the CE is up, but the circuit goes down? Well, you lose your default route, is no longer advertised, so there's a TCP withdraw message that is sent over to CE2 to say there's no longer a default route via local preference 200, so now your egress point will be PE2. So what you would do is you would actually come in CE1, but then you would ride over the BGP peering, the iBGP peering, to CE2 and then go out PE2. So is that suboptimal? It is. So how would you fix that? Well, the answer is simple, actually. What you would do is you would create an IPSLA instance to track this IP address, right? The next hop IP to where you're connected to. You would configure tracking, and you'd call the SLA instance. The tracking would be associated to your FHRP, HSRP, VRP, doesn't matter. And then you would track reachability. So FHRP would then call tracking. So what would end up happening is if the link to PE1 went down for whatever reason and the default route went bye-bye, what would end up happening is the SLA would fail, tracking would fail, and then you'd have a decrement of your priority on your HSRP connectivity, which would automatically make this guy go not as primary. This guy would become primary because his priority would be higher. You would preempt. CE2 would then take over and your traffic would flow this way. So initially, it would actually flow this direction until SLA kicked in. And we're talking probably 30 seconds, maybe, whatever. And then traffic would end up flowing this direction. It would be more optimal. You would bypass CE1 to get there. So that's essentially how, if I'm understanding your question and how you're articulating it, that's how I interpret it. So that's exactly what would end up happening. Done that multiple times. It's a fairly standard edge failover design. So So happy to hear you'll refresh the SD-WAN course. Yeah, it's gonna be a while before that comes, but I do plan on mocking it up. So I first have to go buy the CML 2.7 license. Once I get that and download the new images, I'll have to go through the documentation, understand how to get it all stood up and working, and test it all out. I'm not sure if I'll go through what I did, all the variations that I did for the first SD-WAN series that I did, but I will probably look at the deltas, what the differences are, and note them. And then I will be like, okay, here are the maybe 8 update videos, how you would onboard, how the UI is different, maybe, stuff like that. Depends on how big of a difference it is. So, love the fact that you dedicated one entire episode to addressing MPLS or BGP ISP core thing. Yeah, it's one of those things where you really have to, it's not really that involved, but, So, so regarding your last video on ISP core, I understood most of what you said and really enjoyed it. There's one point I dropped though. You were explaining how IBGP route reflectors are used compared to full mesh on the ISP core, which is understandable, and you explained it in a great way. But my question is, why do we use IBGP in the core to begin with? Is it to avoid redistribution from PE to P, which takes a huge amount of resources and CPU utilization, if my understanding is correct? So if you're talking to straight internet, yes. So there's scenarios where, so actually, let me go ahead and pull up on one of my other servers. Is it this one? I don't remember. I think it is this one. And I'll show you exactly what I mean. I'm giving the lab needs a minute to load. So let me close this lab out. Let me go ahead and pull this one up. Actually, no, it's not this one. Is it? No. Wrong server. Let's do this instead. Okay. Is this what I'm looking for? IBGP. Yep, here it is. Let me go ahead and open that one up. All right, so let me kind of walk you through what's going on here. This is a big topology on purpose. It's supposed to be a hardcore BGP lab that I'm working on. That's going to cover, it's supposed to cover BGP and large-scale multicast. And so what ended up happening was, and I built the lab intentional wrong in some respects to highlight why you wouldn't do things a certain way and why you would do certain things a certain way. So the issue here is, and the reality of networking is you never would have a RFC 1918 address, so 172.31, on the public internet. However, because of the fact that I plan on having large-scale multicast, I did it just because I could, right? Normally you would have the public addresses in the BGP table and all that type of stuff. So to answer your question, one of the things that I had to do, let me go ahead and open up Secure CRT real quick just because I need to show you what I had to do. What I had to do was when I was trying to get CE41 to talk to CE35, it wouldn't work. And at first I was like, well, I've got BGP, I got route reflection, this is actually a confederation. And when I tried to get the next top processing, all that type of stuff, I was like, why is it not working? So do I need BGP here to do the job? I actually do. Now, this is a route reflected design, and but confederation. So this route reflector is handling these 4 routers, and this route reflector is handling these 4 routers, and there's eBGP confederation peerings between R2, R3, XR18, and XR19. And route propagation is happening internally. So what ends up happening was when traffic would, this subnet right here would end up getting an XR20, he would see it. However, because of the fact that route reflection wasn't spread across the entire fabric, I needed to redistribute the BGP learned routes into IGP. And that's exactly the reason why you wouldn't build it out identical to this. You would have you would do your confederations and you would do your propagation. But at least in my experience when dealing with confederations, I always keep them small so that when you're doing them, because route reflection only works with IBGP peerings. So intentionally built it wrong so I could see the caveats, right? It was one of those things where I knew better. I was kind of cringing when I was building it. I had to do the same thing on R7. Even though the route reflection is end-to-end, it doesn't matter because of the fact that R5 is not BGP peered, so it's a BGP-free core. Literally, the core routers, 23, 25, 7, and 6, don't have BGP running at all. They just have IS to IS. So because of that, and I'll click on router 5 just so you guys can see this. If I bring this over and I do a show IP route, you're going to see a bunch of external routes. Now, IS to IS doesn't show it quite as nicely as OSPF does, but all this stuff right here, these are all redistributed routes. If I look on R7, go ahead and pull up R7 real quick, and I look in here and I do a show run section BGP, underneath the address family, I'm sorry, no, it's IS to IS. I had to go underneath both IPv4 and IPv6, and I had to redistribute BGP into the IGP. Why did I have to do that? Because R5 didn't know how to get there. This only applies if you're not doing MPLS. If you're doing MPLS, this does not come into play. And the reason why it doesn't come into play is because the internal routing already knows how to get to where it's got to go. So your next hop will always be the LDP next hop. So wherever your IBGP VPN-v4 next hop is, that's going to eliminate those caveats. So if you're doing MPLS, you don't have that problem. You don't need to redistribute anything from your PE BGP peering into your IGP that LDP would use for connectivity. You don't need to do that for internet connectivity or outside access. And that because of the fact that a VPN-v4 next hop takes care of that for you. It already knows how to get there because of the label binding. So because of that, if you're not doing MPLS, you do need to have that in play, which is why I had to redistribute BGP into the IGP so the IGP would know how to get there. So that's where that comes into play. Now, typically speaking, what you would do is not what I'm doing here. So what I'm doing here on CE41, for example, is if I look in BGP, show run section BGP, I'm advertising into BGP the RFC 1918 space. You normally would not do this. You would advertise the public address space. Now, I did this on purpose to demonstrate why you'd have to do things a certain way. Now, if I look at, say, R2, right, do a show IP route here, you're going to notice there's a lot of stuff. And here, OSPF is a little bit more thorough because it shows you all of the external connectivity. So everything that's a regular O route, and I'll just do OSPF, anything that's just a regular O route, intra area, right, all this stuff right here, is internal to this service provider, right? They all know how to reach each other via OSPF. The drawback is when you do something like this, if the internal routers don't know how to reach it, they're going to drop the traffic, right? There is no default route. But it wouldn't help anyway, because even if I had a default route, maybe 26 is originating it, it doesn't matter, because 26 wouldn't know how to get there either. It would just, dump everything into 26, and 26 would be like, I don't know what to do with it. So he would just drop the traffic, throw it in the bit bucket. So when you're doing MPLS, this isn't a problem. When you're doing non-MPLS forwarding, IP routing, it does. So keep that in the back of your mind. So even though your comment is, why use BGP in the core to begin with? It's because of the fact that that's how the internet works. So if you are in a large-scale deployment, the first thing you're going to do is anywhere you have connectivity in the network, you're automatically going to do a full mesh of peerings or use route reflection, and you're going to be dealing with public addressing. So your internal routing, your edge, there really won't be a core per se. You'll have rings connected to other backbone connectivity and things like that. But in most cases, you're not going to be building topologies like I am. You're going to be building topologies in a ring-style fashion where your ring is connected back to some sort of inter-regional backbone, and then that they're all connected to each other. So no matter where you are on the network, you have a full picture of the network wherever you want, and you're going to be forwarding based off of public address, not RFC 1918 space. So, but most providers I'm familiar with run MPLS in their backbone because it eliminates the need. If you do build like this, right here, if you do build like this, you need redistribution on your edge. If you do MPLS, you don't. It just comes in and you dump the traffic in. It's labeled on the PE, and as long as the PE has a label for it and the route reflector knows how to get there, problem solved. You don't even need to think about it. That's why things are set up the way they are with that. Hopefully that answers your question. So after digging deeper, is the point of multi-protocol BGP to utilize the feature of MPLS with BGP neighbors in an ISP network, such as fast rerouting, TE, QoS, VRFs, and to create VPN labels which will allow very fast reroute? No. No. So multi-protocol BGP, multi-protocol just means that it supports multiple address families. That's what multi-protocol BGP comes into play, and it's different applications. So you've got layer 2 VPL, layer 2 EVPN, I think is the address family, which is going to be for doing any type of VPLS, whether it's LDP or BGP signaled. You're going to have VPNv4, VPNv6, IPv4, MVPN if you're doing like multi-point LDP. So the BGP peering itself is irrelevant, where depending on how you want to use it, so if you're doing fast reroute, MPLS TE, those are going to be dedicated label spaces. Well, I'm sorry, they're not dedicated label spaces. It's a dedicated protocol. So if you're dealing with old school TE, that's a resource reservation protocol, RSVP. So what'll end up happening at a high level is, let's assume that, come here, every one of these routers right here is running MPLS TE. So that means it's enabled for OSPF. All these interfaces have TE tunnels enabled on them, all that good stuff that goes along with that. So when you have that and your TE database is built, so you know who's everybody, you know where everybody's at, all that good stuff that goes along with it. So if I have a scenario where my dynamic path, so RSVP figures out what's going on, and you use the dynamic path. So there's IGP and then TE metrics that go into play with that. So let's assume everything's going based off the IGP metric. So the fastest path from R1 out of the network to CE41 is directly this way. So you could create a TE tunnel that would be signal to XR20, which would be the tail end of your, so this would be your head end, this would be your tail, and then you would signal a path. But let's say, for example, you want to set up another path where tunnel 2, for example, has an explicit path that goes to R3, to XR19, and then down to XR20. So this would be the same amount of hops, it just takes a different path. So what could you do in a scenario with this? Your explicit path is where your fast reroute would come into play. Now, with both your dynamic path and your explicit path, what will end up happening is you're going to do what they call a path check. So you're going to send RSVP path messages this way just to make sure that all the constraints are matched. Bandwidth, affinity, metric, administrative weight, all that type of stuff is going to get checked. And assuming that all those constraints match, then your tunnel will come up. Same thing happens with explicit. So you take the path through R3 to XR19 to XR20, and everybody's happy, right? So what you do with this path is, and what you would do is you would turn on fast reroute on it, but then on one of these devices, so either R3 or XR19, you'd have to do some sort of additional tunneling where, let's say you're going to do next hop, which is link protection. Let's say you want to protect this link. If it goes down, you want to redirect over here to R2. Well, you would configure it in such a way that if something happened with this link, then you would automatically set up another tunnel that would get you from R3 to R2, and then from R2 would get you to XR18 and then over to XR19 because that's your TE path, your explicit path, and then XR19 would follow this path down. That would be a fast reroute. Now here's the thing with fast reroute. It's a temporary solution. So I believe it's a 3 minute. We'll just put 180 seconds. I think it's a 180-second timeout. I could be wrong on that, but even if that's the case, then when you get into those type of situations, that's going to be when the path message is sent, regardless of it's a dynamic or an explicit path, it doesn't matter. You're going to send path messages via RSP down, but then you're going to get reservation messages back, and the reservation messages back from the tail to the head are going to assign the labels. That's where if you do like a show MPLS TE topology database, it's going to, or tunnels, it'll tell you what the label value is that's been assigned to it. So that the TE path takes a certain path. So, and the same thing with R3 for fast reroute. So if that was the case, then you're going to, and then on this guy here, you'll have a fast reroute database, which will have a local here, say ready, to see if there's link protection and things like that. R1, it'll see that there's nHop protection on the link on R3 when it does its check. So you have all these variables that come into play with that. So the label that is assigned for TE labels, regardless of if it's fast reroute or not, all come from the global range. So that you had that to take into consider, right? You get like 1,050,000. It's like 0.48 and change labels, the global label space. That right there is why you don't redistribute your entire internet routing table into your IGP. That's why. Because you're going to blow out your label capacity on a per device basis. And what you're trying to do is keep it as tight as you can so that you're not having a whole bunch of traffic coming in and sucking up all your labels. That's why you get away from that. Now, there are scenarios where the capacity would be okay, and you can do like a per VRF where instead of every label gets a prefix, you do only one label gets assigned per peering. So regardless of how many subnets you learn, you're only going to assign one label. There's some optimizations and things like that, but that's essentially where that comes into play. Now, your other question was about QoS and something else. I'd have to go back and look at the question. But, so let's jump back over there real quick. So fast rerouting TE, QoS, BRFs, and to create VPN labels which will allow very fast rerouting. So fast reroute is its own dedicated thing. So it's an enhancement to TE. So going back to what I was talking about here just a second ago, if you have QoS, you can come in here, and if you're doing, the only way to do bandwidth reservations is you have RSVP, because that's the only thing that will look at bandwidth, and you can do a bandwidth reservation. And if you're doing that, then you get into what they call diff serve aware TE. And then you have a couple of different models that you can work with. You have Russian dolls, and then you have maximum allocation model, where Russian dolls allows you to share bandwidth between different class types, where maximum allocation model means you have a bandwidth constraint that's tied to a class type, and you're not allowed to share the traffic. This is kind of restrictive. This is very, very flexible. So if you want to know more about that, I'm planning on covering some of that down the road, but it's one of those things where it's going to take some time to go through the material. But I hope that answers your question, and that's how I understand it. And I'm still no expert on MPLS TE or on fast reroute, so I improperly or incorrectly worded something or whatever, then those are situations where I can definitely adjust down the road, but I'm still learning. Oh, wow, I did not realize it took that much time to describe and break that down, but anyway, that's okay. Let's see if I can answer one or two more here real quick. I have a very big problem with translating debug alerts. I study the topic well, lab it, study it from lectures and OCG many times with Google. I just can't make out what the debug is saying at all. It makes me feel like I never understood the protocol to begin with. I mean, that happens. I've looked at debugs in the past too when I was troubleshooting stuff, and I'm like, I don't understand what this is trying to say. And if you try to Google it, there's really not a whole lot out there. So maybe it's the first time someone's trying to do something or whatever. But I've oftentimes, especially if I have support on hardware, I'll be like, hey, can you take this, this chunk of information? Can you open up a TAC case and ask them to see if they can't decipher it for us? Because I don't know if this is relevant or not, and I don't want to be like, it is what it is. So that's usually how I like to handle those type of things. So don't feel bad if you have looked at some information and you're like, I just don't know what this means. Most of the time, it's pretty straightforward, but other times it can be like trying to read the hieroglyphics from the pyramids. So we'll do this last one real quick. By complex VPNs, I was referring to MPLS layer 3 VPNs. I'm really glad you dove into DMVPN. Yeah, it's okay. So, okay, here we go. Okay, this one might take a minute. Let's say Bank A and all its branches in a country are under the same VRF by the ISP. However, the bank's certain updates need to be visible to the central bank to ensure there is no violations of monetary policies. So let's say the central government bank is called Bank B. So Bank A has a VRF of its own, and it's still under the VRF, but it is still under the VRF of Bank B as well. So it's a VRF and a VRF. So Bank B can import certain updates from Bank A, but not necessarily vice versa. From my understanding, these type of complex are popular in SP track. So what you're talking about is similar to what they refer to as inter-VRF route leaking or shared services. So you can do that, and you can leak routes by doing a couple different ways. A very kind of dirty way of getting it done, and I've done it in the past, is just to simply import route targets from a different VRF, and then you just get a full dump of the whatever's in that other VRF. You see every route. That's one way of doing it. I wouldn't say complex. In my opinion, that's not complex. Complex is a little bit more involved where you're using import policies, using route maps, which you call prefix lists, and then you match on what traffic you want to allow to go back and forth. I probably will cover that just because of the fact that it is kind of a unique topic and not very widely deployed. So, yeah, that's not too terribly difficult to do. But shared services typically is where there's a merger or an acquisition of some type, and when you are doing that, you would sometimes overlap the route targets so that you can allow customer A and customer B to see each other's routes and have reachability. So that type of stuff does happen. Okay, so I'll cover one last more. I'm still trying to understand the outage you faced with a customer once regarding the DMVPN, high CPU, keying issue. Why does restarting the DMVPN hub resolve the utilization issue? In what way does restarting the device have to do with CPU utilization? Oh, you're confusing two different things. So they happen basically the same day, though. So I had a customer that had a DMVPN environment where the hub was at a HQ location, and they had phase 3 deployed at a spoke and then another spoke. And the idea was they wanted, if the local, for exactly how it worked out, but if there was a local IT support was at the spoke, he wanted to be able to VPN directly to the other spoke without having to go through the hub to get to where he had to go. And he realized that latency was a little high or something. Something made him realize that he wasn't going directly to the spoke. So when he reached out to us to take a look at it, and I tried to get the off hours, I tried to get the VPN to clear to see the crypto process had hung. It wasn't a high CPU thing. So I opened up a TAC case because I tried clearing it myself, minus a reload. And TAC looked at it. They were like, we need a reload. He actually showed me some internal documentation that says when you run into this problem, especially on this particular platform, the only way to get around that is to reload the router. So I let the customer know. We scheduled a date and a time. Boom, problem solved. That was that. The high CPU you're thinking of, I remember talking about, was a Cisco chassis switch. I think it was a 6500 or a 4500 connecting down to a pair of like 3700s or something like that. And they had LACP deployed for the port channeling for the negotiation. And what ended up happening was the the distribution or core switch had 90-95% CPU. I don't know why. The switch didn't have support at the time, so we couldn't open a attack case to have them look at it. So I ended up sluggishly, because the CPU was so high, removing LACP and just configuring a static port channel, so the port channel would always be up, but they would still have high CPU. And the CPU was so high that it was causing LACP BPDUs to get dropped, therefore the port channel would drop. So by configuring a static, it was always on and always passing traffic. It was a workaround. So that's where that came into play. I've never had a router. Well, actually, take that back. I did have one scenario where we had a large amount of DMVPN spokes landing on a router, and the CPU was always at 70-75%. And when I looked into how the crypto engine worked on that particular platform, it was software-based crypto. It was a general-purpose CPU on the router handling it. So I made the suggestion we need to go to a router that's got a dedicated hardware engine, or offload the crypto to its own module. So it was an ASR 1002, I think. One of those ASR 1000 series routers had a dedicated crypto module to where the processing was done on its own chip and not the general-purpose CPU. So I forget, about a month maybe it took to get a new router in, and CPU dropped dramatically from like 60-70% down to like 15 or 20. But it wasn't one of those things where you wanted to, what do you call it? We had to, when you're having 400 or so DMVPN sites come online, it's going to spike the CPU no matter what, because you're bringing the box online. So we did it after hours when we wouldn't have to worry about trying to pass traffic. We were just worried about trying to get the control plane to settle down. But we did right size the box. We talked to Cisco, and their SC helped us out with that. So anyway, that's that. Hopefully that answers some of your questions. And I'm going to shoot to the top here real quick to answer a couple other questions real quick. So we answered that, and he noticed. So hey Rob, have you ever considered collaborating with other YouTube network engineers? I think you were right in your video the other day in terms of there not being a huge demand for the more technical videos. Could be worth exploring. Yeah, I will ping you directly on that. I'll see if there's, I don't know if I'll be able to ping you directly or not, but I'll respond to that one. How do you handle multiple competing priorities and projects? I find myself switching between so many projects and operational problems that it is hard to balance it all effectively. I operate on the prioritize and execute model, which means if I have competing priorities, I always try to do my best to attack the one where I have a deadline due with the closest deadline. So you're always going to be kind of under the gun in that respect. So for example, if it's a Monday and I have a deliverable due on, say, Wednesday morning for a project, and I also have another deliverable due, say, Wednesday afternoon, I'm working on the deliverable for Wednesday morning. But if something happens, like let's say I get in the office at 9 o'clock in the morning, and then I find out that, hey, the project that had the deliverable due on Wednesday afternoon is now considered more priority, then I shift my focus over to the one that's got a higher priority value. So, and I let somebody else tell me what the priority level is. I don't make that decision myself. So, whether that's picking up the phone and calling somebody or whatever, just the situation as it handles. So, yeah, it's always going to be a balancing act, no matter how you go about doing it. It's a balancing act now, and I don't have to deploy anymore, which is really nice. This one right here came in just a minute ago. Hi Rob, thank you for answering my question. I also think that just layer 2 link trunk between distribution switches is the best design. You also mentioned it is possible to run routing protocols with SPIs over layer 2 trunk between distribution switches, and wanted you to explain something about it, and then your attention was switched to another question. Could you please tell me more about the design? I think it's not very usual design. And in which kind of scenario would you use it? I also wanted to tell you about load balancing virtual devices for real-life networking course topology, Citrix Nextscaler, and big F5 Big IP images are supported in EVE-NG. Maybe you can use them for your topology. That's possible. I haven't really played with F5 or Netscaler, so I'm not exactly sure how that would work. I have no problem learning it. It's just one of those things where I have other priorities that are taking the bulk of my time, and that's where my time and effort sits right now. Is I'm learning network automation and assurance for the ESP track. So I'm learning network services orchestrator. So there's some good training through Orhan Ergun about that. So I'm learning how all that type of stuff comes together because it's like it's necessary for me to be able to uh, attack the lab exam. Anyway, that is pretty much what I was going to cover today. I went actually a little longer than I wanted to, but that's okay. Anyway, if you guys have any questions, comments, concerns, feedback, drop that in the comment section below. I will have links to the Patreon link for membership if you can't do it through YouTube. The sample workbook and the actual workbook will be in the links below in the description. And then I'm looking forward to seeing all of you that are members that want to hang out with the coaching session tomorrow night at 7. So I should be home by then. So I'll be able to knock that out. It'll be, we'll do NAT exemption with IPsec VPNs. So that'll be probably the first 15, 20 minutes or so of the session. So maybe we'll talk about other stuff. But anyway, yeah. Thanks so much for stopping by and hanging out with me, and I'll catch all of you in the next video.